Welcome to this session of the Highway Capacity Analysis video series. This is the fourth in a series where we've talked about some reasons behind choosing the HCM and HCS for your analysis, digging into the details to understand how to do the best analysis possible by attending training, how important multiple period analysis is to congested signals, and how to get the correct answer in those analyses. And we've also done one about optimizing signal timing. This is trying to answer questions related to modeling the access points to side streets and driveways between signals along the arterial segment. The procedure is done with a flow profile that models the platoon from one signal to the next. I'll show you a little bit about that, and the access points between signals can influence that platoon, and the flow profile is modeling that influence, and this can make a significant difference in the results if there are enough access points and or activity in and out of them. Again, this is from the Highway Capacity Manual 6th edition as implemented by Highway Capacity Software Release 7. The research-driven with millions of dollars of research behind it and peer-reviewed by 200 experts as part of the committee process. So if you look at this picture, you get a sense for the movements that are coming from the upstream signal and headed to the right to the downstream signal. And we're trying to model the proportion arriving on green. How well are these two signals coordinated, and what's that platooning effect on the arrivals downstream? And when you do signal timing optimization or you draw a time-space diagram, you're many times just looking at the time it takes to get from intersection 1 to intersection 2, and you're not considering the things that might influence that time along the way. If you think about driving down an arterial and you're going 45 miles an hour, the car in front of you decides to slow down and turn into a side street or a driveway, slows down to 10 miles an hour, you slow down to 10 miles an hour, the car in front of him keeps going. So what that means is every time a car turns in and out of a side street or a driveway, the platoon breaks up into pieces with gaps in between what used to be a contiguous platoon, and the speed from intersection A to B is decreased. And that causes the platoon to arrive later and in pieces. The decay is where it breaks into pieces. And this flow profile shows two very well coordinated signals with no access point influence essentially. And you see this represents virtually all the through movements from the upstream signal arrive during the green downstream. Even the side street left turn is sent downstream and gets there in time for the green. The side street right turn maybe not so much. But if you have access points that slow this platoon down, this big mountain starts to lean because it takes it longer to get downstream. Many more cars arrive on the red. And if it breaks it into pieces, not only does this lean, but it breaks up and even more and more cars arrive on the red. So the influence on access points on the proportion arriving on green can be very, very significant. Talk to any signal timing engineer and they will talk about fine-tuning. Fine-tuning is overcoming the influence of access points that the optimization tools don't look at. But in this case, you don't need fine-tuning because the optimization tools do model that influence in a very specific and precise way. So just talking about access points influence, the multiple period analysis importance on congested signals to get a much better answer if the signal is congested. In fact, you can't even get close to a right answer for a single period analysis in a multiple signal, in a congested signal. And also optimizing signal timing with both the multiple period analysis and access point influence using the flow profile and phase duration models is got to be the best way to do this. So here's my contact information. Please let me know if you have questions, if you're trying to compare this with somebody else or some other tool. Anything you think I might be able to help with, please let me know. Thank you for tuning in, and thank you.